This lesson video will introduce you to our first simple system for evaluating arguments for validity. But before we look at that system, syllogistic logic, we're going to need to cover a few more useful concepts for representing the abstract form of particular arguments. So the way the lesson's going to go, we're going to talk about how to use variables to stand for the content of arguments. We're going to look at using substitution of concrete terms and statements into argument forms. And then with that under our belt, we'll be able to move on to recognizing instances of the basic statement forms of syllogistic logic, as well as several valid argument forms. So the first concept we're going to need for today is variables. We use variables in logic to capture the form of an argument. So in math, you're probably familiar with the idea of using variables to stand in for numbers in an equation while leaving in the mathematical operations. With 7 plus 4 equals 12, in that equation, we can take out the numbers and replace them with letters, variables that can be replaced with other numbers. That represents the operations involved in that equation without talking about any particular numbers. So by using variables, we can keep the form of the equation the same and then change around the actual numbers involved. So you could also have 3 plus 2 equals 5. And we do something similar with sentences of English. So in logic, we use variables to stand in for the simple terms or statements in our arguments. And then we leave in the logical words that connect those terms or simple statements. So here's two sentences that have the same structure, but differ in content. If I finish my work by Friday, then I can go to the beach this weekend. Politicians have to appeal to their constituents if they want to get reelected. So for these statements, we can use propositional variables, ones that stand for statements, to show their common form. So they both have the form if P, then Q. To get the first concrete example, P was replaced with I finish my work by Friday. And in the second example, it was replaced with politicians want to get reelected. So that was the P replacement in each of those. And Q was replaced by I can go to the beach this weekend in that first example, and politicians have to appeal to their constituents in the second example. And we can go both directions, from form to particular statement, or from particular statement to the form. So we can replace content words with variables to capture the form. And then once we have the form of a statement, we can replace the variables with any appropriate bit of English. And it was just the fact that in this case, the variables stood in for full statements. But when we look at syllogistic logic in a few minutes, we'll see that sometimes variables stand in for terms or phrases instead of sentences. What the variables stand for depend on the rules of the particular logical system that you're using. The advantage of using variables is that it allows us to represent the form of the sentences that make up an argument without worrying about the particular content involved. So here we see to the right a full argument that uses one of the statements from the previous slide. And then to the left, we have the form of that full argument. So the form is if P, then Q for the first premise, not Q for the second premise, and not P for the third. So as I read the full argument, listen for the if-then and for the not. If I finish my work by Friday, then I can go to the beach this weekend. I couldn't go to the beach this weekend, so I didn't finish my work by Friday. This argument is an instance of the argument form to the left. And again, remember that the value of using variables and argument forms is that by seeing the form of an argument, we're better able to determine whether it's invalid or valid without being distracted by the particular topic it's about. To generate statements of English or arguments of English from statement forms or argument forms, we use substitution. This should seem pretty straightforward. We substitute an English word, phrase, or statement in for the appropriate variables in the form we're given. We'll see that there are a few rules for how we do this in a second. But if your statement form is something like if P, then Q, the variables P and Q are variables for statements like it is raining and I will take an umbrella, letting us generate the full concrete sentence, if it is raining, then I will take an umbrella, from that logical form, if P, then Q. In addition to the statement variables we've looked at so far, note that we can also have variables that are replaced by words or phrases. So this middle example is such an example. The statement form, not all X are Y, has variables for terms. So X and Y stand for terms. And that means something like verbs or generic nouns. So as an example, we could substitute mammals for X and cats for Y to get not all mammals are cats from not all X are Y. So the statement, not all mammals are cats, is what's called a substitution instance of not all X are Y, the form. A substitution instance is a concrete statement or argument gotten by substituting the appropriate bits of English for the variables. And each instance of the same variable, X, Y, etc., must be replaced by the same term or statement. So every time you see an X, it has to be replaced by the same thing. So to emphasize that each variable must be replaced by the same term or statement, depending on the kind of variable, let's look at an example. Not all X are Y, but all Y are Z. We can replace X with mammals, Y with dogs, and Z with dogs. What matters for a substitution instance is that every X is replaced with mammals, every Y is replaced with dogs, and every Z is replaced with dogs. So not all mammals are dogs, but all dogs are dogs, is a substitution instance of the form above. We can slightly refine that notion with the notion of a uniform substitution instance. And this tends to be the one that's a bit more useful for our logical purposes. So a uniform substitution instance is one where each instance of the same variable must be replaced with the same term or statement. That's the same. But also, each distinct variable is replaced by a different term or statement. So in the previous, Y and Z were both replaced with dogs. That's not allowed with a uniform substitution instance. So here's the same statement. To get a uniform substitution instance, we had to have different terms for X, for Y, and for Z. So we have animals, dogs, mammals. And that gives us a uniform substitution instance. Not all animals are dogs, but all dogs are mammals. Why do we have this notion of a uniform substitution instance? It's because arguments and statements have the same form if they are uniform substitution instances of the same argument or statement form. So here we can say that these two arguments to the right have the same form because they're both uniform substitution instances of the argument form on the left there. So this is the same argument form we looked at before. The first argument is the one we saw before too. If I finish my work by Friday, then I can go to the beach this weekend. I couldn't go to the beach this weekend. Conclude, I didn't finish my work by Friday. Here's an argument with the same form. Again, listen for that if-then and the not. If cats are aliens, then they can read minds. Cats don't read minds, so cats aren't aliens. So when we know arguments have the same form, we can conclude something about them based on their logical form. We can conclude that they have similar logical properties, like validity and invalidity that we covered before.